When I first looked at the early observations of 3I Atlas, I expected another faint, unremarkable interstellar visitor. Most such objects pass through our system quietly, leaving behind nothing more than a trail of numerical data. But something about this one refused to align with the usual patterns, and the more I reviewed the measurements, the more I realized that the numbers themselves were raising questions no one was prepared to answer. 3I Atlas was first detected in mid 2025 by the Atlas Survey, the same network that brought us several unusual comet candidates before. On paper, it behaved like a typical interstellar body: hyperbolic trajectory, high closing speed, no known prior association with our solar system. Yet even those first readings hinted at a structure and motion that didn't quite fit. Some brightness variations appeared sharper than expected. Several observatories reported small inconsistencies in the reflected light curve, almost as if the surface was more uniform than that of a natural fragment. Normally, a comet entering sunlight develops outgassing signatures: jets of sublimating ice, chaotic changes in rotation, irregular shifts in brightness. But Atlas did none of that. Its photometric behavior stayed strangely stable. Some astronomers described the pattern as too orderly, though few were willing to speculate publicly. Stability doesn't necessarily imply design, yet the lack of natural irregularity was the first detail that made me pause. I kept wondering why the data did not show the noise we usually expect from a body of this size. As I traced the subsequent sets of observations, another detail emerged. The shape estimate, derived from rotational light curves, suggested a geometry that leaned closer to a triaxial form than to the lumpy, uneven profiles we associate with most interstellar fragments. These reconstructions are not definitive, and they often change as better data arrives, but the early models displayed an unusual consistency across instruments. Several independent teams generated nearly identical orientation solutions. That kind of agreement is uncommon. It made me think about whether the object was smoother or more uniform than expected, and if so, what could produce such uniformity. Some researchers quietly noted that parts of the radar spectrum showed faint banding structures that were difficult to classify. They might have been noise, they might have been processing artifacts, but a few analysts hinted that the pattern looked regular, almost like a repeated internal scatter rather than a chaotic one. No one could confirm it, no one could explain it, and within days the relevant files were revised and standardized. To this day, I still don't know whether the original version was a mistake or whether someone simply preferred a cleaner data set. Of course, there are natural explanations. Interstellar objects are shaped by processes far more chaotic than anything within our own system. A foreign body may carry unusual material composition, or reflect light in ways we are not used to interpreting, and yet the absence of randomness, the quietness, the stability, kept resurfacing in every discussion. It felt less like analyzing a wild fragment of cosmic debris, and more like examining something that maintained its own internal balance. Several astronomers, speaking informally and off record, mentioned one more strange coincidence. Deep space instruments monitoring background radio noise registered a mild electromagnetic variation in the same window during which Atlas was first identified. It was weak, well within natural limits, and entirely explainable as interference. Still, the timing raised eyebrows. These coincidences often mean nothing, but they tend to linger in the back of your mind when enough of them appear at once. I am not saying the object is artificial. No credible scientific report claims anything of the sort, but I am saying that 3I Atlas behaves differently from what we expected. The stability of its rotation, the uniformity of its reflective structure, the lack of chaotic outgassing, these are anomalies worth examining carefully. And even if each individual observation has a natural cause, the combination of all of them leaves a quiet, persistent question behind. As Atlas moves closer to the Sun, new data will inevitably arrive, and with it either clarity or even more uncertainty. For now, I can only note the unusual patterns and the missing explanations. Whether they amount to something significant or simply reflect the limits of our current models, that remains unclear. What happens next will depend on the observations we have not yet seen, and on the ones that may already exist but haven't been released. For now, the mystery sits quietly between the numbers, waiting for the next set of signals to reveal what this object truly is. I kept returning to the same thought. No matter how many natural explanations I considered, the behavior of 3I Atlas still felt unusually controlled, and that feeling only grew stronger as new observations arrived from the following week. Although the earlier data had hinted at stability, the next sequence showed something even harder to reconcile: a subtle, persistent change in the object's rotation. At first it looked like a measurement error. Rotational irregularities are common, especially when instruments shift between atmospheric conditions or calibration cycles. But this shift wasn't random. It followed a clean, gradual curve, as if the object were adjusting itself rather than being pushed by sunlight or outgassing. The change was tiny, almost negligible, Yet the precision of the trend line is what kept me awake. Natural bodies do change rotation, but rarely with such quiet uniformity. When I compared the datasets from different observatories, another detail stood out. Several teams registered faint periodic reflections, tiny pulses of enhanced brightness. They were far too weak to draw conclusions from, and most analysts dismissed them as stray reflections or internal scattering in the instruments. Still, the timing was curious. The pulses repeated at nearly identical intervals across widely separated observation windows. Not perfectly, but close enough to feel deliberate. I remember staring at the timestamps and wondering whether it was just statistical coincidence or the signature of a surface more structured than we assumed. There is also the matter of the radar return. A joint experiment using multiple deep space antennas attempted to probe the internal composition of Atlas. The results were mostly inconclusive. Interstellar bodies often produce noisy echoes due to unfamiliar material composition. Yet one particular band returned what some described as a layered scatter. It wasn't strong enough to confirm structure and not irregular enough to dismiss outright. The analysis report used careful language, emphasizing uncertainty, but privately several researchers admitted the pattern resembled a repeating internal boundary rather than a chaotic interior. No one publicly endorsed the interpretation, and the document was revised within 48 hours. I can't say whether that was routine editing or something more cautious. Alongside the official channels, a stream of unofficial comments circulated among specialists. One astronomer, who asked not to be named, claimed that an early infrared scan detected temperature variations arranged too symmetrically to be natural. Another warned that the data might simply reflect calibration artifacts. The truth is, we don't have enough information to make firm claims, but the fact that such concerns were raised at all is notable. Scientists tend to avoid speculation unless the data forces them to reconsider their assumptions. Meanwhile, radio observatories reported a phenomenon that proved difficult to classify. During a narrow time window, a faint electromagnetic fluctuation appeared across several monitoring stations. It wasn't strong enough to qualify as a transmission, and it didn't match any known artificial source, but its frequency drift loosely aligned with Atlas's trajectory. The official explanation attributes it to background variability and cross-instrument interference, both entirely plausible. Still, several analysts privately questioned whether the timing was too convenient. The fluctuation began shortly after Atlas entered a region of increased solar radiation and faded just as quickly. If it was nothing, it was an oddly timed nothing. All of this, the rotation shift, the repeated brightness pulses, the ambiguous radar scatter, the unexplained radio noise, could have natural origins. Interstellar objects are still poorly understood. Their long journeys expose them to forces we cannot fully model, and their surfaces often contain exotic materials. The absence of outgassing does not prove artificiality. The stability of rotation does not imply machinery, and yet the collective pattern refuses to settle. Each anomaly can be justified on its own. Together they form a series of quiet, unresolved questions. I keep thinking about how little we truly know about objects born outside our solar system. Even Oumuamua, the first interstellar visitor, remains a puzzle years after its passage. Some of the hypotheses once considered extreme have since become part of mainstream discussion. Atlas may simply be another chapter in that ongoing story, a reminder that our assumptions about normal behavior might not apply beyond our cosmic neighborhood. But there is one detail I cannot ignore. As Atlas approached the region just inside Mars's orbit, several telescopes independently reported a slight deviation from its predicted trajectory. The correction was minuscule, well within the range of modeling uncertainties, yet the resulting curve matched older projections almost perfectly, as though the object had aligned itself with the earlier estimate rather than following the updated one. It was probably just an artifact of incomplete modeling. But the analysts who calculated it looked unusually tense during the debrief, as if they couldn't decide whether to trust the numbers they themselves had produced. Perhaps everything I'm seeing is noise, coincidence, overinterpretation. Perhaps Atlas is simply another unusual piece of interstellar debris, shaped by conditions we can't yet reconstruct. But I can't shake the sense that the object is behaving with an orderliness that nature seldom provides. Whether that order comes from physical structure, uncommon composition, or something else entirely, that remains to be seen. For now, all we can do is wait. More data is coming. More signals, more scans, more anomalies, or maybe none at all. And as Atlas draws closer to the sun, whatever answers lie hidden within it will reveal themselves, either through clarity or through mystery. What happens when it reaches its closest approach? That is the question no one seems ready to ask aloud. I kept replaying the last trajectory update in my mind, trying to convince myself it was nothing more than a computational illusion. But as the new measurements came in, I realized that the earlier irregularities were only the beginning. What we observed next pushed the boundaries of what we usually consider natural behavior for an interstellar object. The next set of photometric scans showed a pattern I hadn't expected. Atlas began exhibiting a faint oscillation in brightness, not the chaotic flickering associated with tumbling debris, but a subtle rhythmic modulation. At first I assumed it was a processing artifact, but the same modulation appeared in independent datasets from instruments with entirely different architectures. The alignment was not perfect, but close enough to raise questions. When the variations appeared again during the following observation window, I felt a familiar discomfort. Rhythmic patterns in astronomy usually demand an explanation, and none of the standard ones seemed to fit. Alongside the brightness data, the radar team released another preliminary report. This one included deeper scatter analysis, and although it avoided conclusions, the phrasing was notably cautious. The internal reflections showed what one analyst described as intermittent coherence, a technical term indicating that some echoes behaved as if bouncing off surfaces that were flatter or more uniform than expected. Natural materials can produce similar effects, but usually through repeated or crystalline layers. For something traveling through interstellar space for millennia, such preservation would be unusual. One detail particularly bothered me. The coherence peaks were spaced at intervals that appeared more regular than random geological layering would suggest. No one claimed artificial structure, but the implications lingered in the footnotes. I remember staring at the diagram, wondering whether we were misinterpreting a natural phenomenon or glimpsing something more precise than nature typically provides. Meanwhile, multiple radio observatories detected another faint anomaly. It wasn't a transmission, nothing strong enough to classify as intentional, but over several hours, subtle frequency shifts occurred across a narrow band. Individually, they were meaningless. Taken together, though, the fluctuations roughly aligned with the rotational phase of Atlas. The correlation was weak and officially dismissed. Yet several researchers admitted privately that it was the sort of pattern that tends to create more questions than answers. Then came a development that changed the tone of the conversation entirely. A new orbit refinement revealed a second deviation. Again small, again within modeling tolerance, but oddly consistent with the earlier anomaly. If it were merely random perturbations from solar radiation or measurement noise, we'd expect a scatter of unpredictable shifts. But this one seemed to follow the same directionality as the previous correction, almost as if the object were subtly adjusting its path in response to changing conditions. During the closed session that followed, the room felt tense. Some analysts insisted on natural explanations: thermal emission, asymmetric reflectivity, non-gravitational forces. Others argued that the modeling was incomplete, but a few maintained an uncomfortable silence, as if aware of an implication they weren't ready to vocalize. To make matters more complex, another observational anomaly surfaced. A short-lived infrared enhancement appeared around one region of Atlas's surface. It wasn't a flare or a jet, nothing violent or rapid. Instead, it resembled a mild localized temperature rise. The most likely explanation was thermal inertia responding unevenly to sunlight, but what unsettled me was the shape of the signature. A narrow, elongated region, not a diffuse patch. In natural objects, heating tends to spread across irregular surfaces. This pattern looked more controlled. Several teams attempted to replicate the reading, but by the time they reoriented their instruments, the anomaly had faded. Whether it was real or an observational mirage remains unresolved. As all these small inconsistencies accumulated, the narrative around Atlas subtly shifted. Not publicly. The official bulletins remained cautious, technical, and non-committal. But privately, in the emails and quiet discussions between analysts, a creeping uncertainty began taking hold. No one used the word artificial. No one dared. But several started referring to Atlas as structured, ordered, or coherent, words we usually reserve for engineered systems. Still, I forced myself to stay grounded. Extraordinary claims demand extraordinary evidence, and none of what we had was decisive. Interstellar objects are wild, unfamiliar travelers shaped by forces we barely understand. Unusual behavior does not imply intent. And yet, every time I tried to dismiss these thoughts, the patterns returned. The rhythmic brightness, the layered radar echoes, the temperature anomaly, the trajectory adjustments, each might be natural, but together they formed a mosaic that refused to settle comfortably. Late one night, while reviewing the raw data alone, I found myself asking the question I'd been avoiding. What if the anomalies weren't random? What if they were connected, not causally but structurally? What if Atlas simply wasn't built the way we expect natural interstellar debris to be built? There is still no answer. There may never be. But the closer Atlas drifts toward the inner solar system, the more clearly we see its behavior, and the less easily we can explain it. Every new measurement deepens the puzzle instead of resolving it. And with its perihelion approaching, another unavoidable question emerges, one none of us have the courage to articulate aloud. If the behavior we're seeing is only the beginning, what happens when Atlas gets even closer to the sun? I kept thinking about the question I tried so hard to ignore. If everything we were seeing was only the beginning, what would happen as Atlas moved even closer to the Sun? The object was now approaching a region where increased radiation, solar wind pressure, and thermal stress usually force a comet to reveal its true nature. Yet instead of behaving more chaotically, Atlas grew more controlled, almost anticipatory. The next series of optical scans revealed a development that made even the most skeptical analysts hesitate. Several observatories reported unusually stable reflectance profiles. As Atlas rotated, the pattern of reflected light showed a consistency that bordered on geometric repetition. Not perfect symmetry, but closer than we typically observe in any natural body. When I overlaid the reflectance maps from different instruments, the alignment was unsettling. The bright regions seemed to form subtle, repeating angles rather than the irregular scatter we expect from rough terrain. To be cautious, I cross-checked the data against known calibration artifacts. Instrumental repetition is common, especially with automated systems, but the patterns persisted even after correction. Some faint alignment appeared to track with the object's rotational axis, as though the surface had regions that behaved like panels, though that interpretation was more psychological than scientific. Still, the effect was impossible to unsee once noticed. Meanwhile, radar probing attempts continued. The latest dataset included several high-frequency returns that defied easy categorization. Instead of producing a chaotic energy scatter across a broad spectrum, Atlas returned a handful of unusually narrow peaks. Natural materials can create such peaks under specific conditions, particularly when layered or crystalline, but the signal spacing was sharp enough to raise more questions than it answered. One analyst described the pattern as suggestive of structured density zones, though they immediately softened the statement by adding that natural formation could not be ruled out. At the same time, an infrared anomaly reappeared, this time more pronounced. Over a period of several hours, one longitudinal strip of Atlas's surface warmed and cooled with a smoothness that felt engineered rather than random. Most thermal signatures from sunlit bodies fluctuate unpredictably due to uneven surface composition. Here, the rise and fall followed a gradual curve, almost rhythmic. Several teams proposed explanations involving deep subsurface layers or unusual thermal inertia from materials not yet catalogued, but a few whispered that the smoothness of the curve resembled controlled thermal redistribution rather than passive heating. Then something even more puzzling occurred. Radio observatories recorded an irregular, faint, pulse-like fluctuation in the background noise. Not strong enough to be a transmission, and not consistent enough to call a signal, but the peaks correlated loosely with the thermal cycle recorded earlier. It could be coincidence, many things in astronomy are, but coincidences become harder to dismiss when they line up across different data sets. As the days passed, the atmosphere in the analysis teams shifted noticeably, not toward sensationalism but toward caution bordering on unease. Even the most rigorous skeptics stopped dismissing anomalies outright. Instead, they phrased their doubts more quietly, as though careful not to step beyond the limits of acceptable interpretation. The phrase non-standard behavior began appearing in internal reports, replacing the earlier likely variance. Terminology softened, but uncertainty sharpened. It was around this time that the trajectory team produced a new update. Atlas had deviated again, just slightly, from the projected path. The shift wasn't alarming, but it displayed a consistency with earlier deviations. Not random drift, not dispersive force, but a subtle directional correction that maintained a near-perfect alignment with its revised orbital plane. When the team presented the findings, the room fell into one of those silences where everyone thinks the same thought but no one dares to voice it. During the next closed session, someone suggested that the deviations might be the result of previously undetected outgassing jets. That would have been the simplest explanation, but when the photometric data was examined, no corresponding jets were found. No fan shapes, no tails, no anisotropic emissions. The entire surface remained eerily calm with no sign of the violent behavior that typically accompanies non-gravitational acceleration. With every passing hour, Atlas behaved less like a comet and more like something preserving its own stability. Whether that stability was natural or the result of an internal mechanism remained a question no one could answer convincingly. Late into the night, while reviewing the compiled datasets, I noticed something else. Nearly every anomaly, brightness modulation, thermal smoothing, radar coherence, radio fluctuation, trajectory alignment, became more pronounced as Atlas approached the inner solar system. The pattern resembled a system gradually becoming more active or more reactive as environmental conditions changed. It didn't prove anything, of course. Natural bodies often exhibit increased dynamism near their perihelion, but the way Atlas changed felt less like a reaction and more like a response, and that lingering thought, that subtle shift in interpretation, was becoming increasingly difficult to dismiss. Whatever Atlas is, natural or otherwise, its behavior is evolving as it draws closer to the sun. and once it reaches perihelion, the point of maximum solar exposure, the object will either reveal its nature fully or conceal it even further. Which possibility should concern us more? I still don't know. I kept thinking about how every anomaly intensified as Atlas moved deeper into the inner solar system. By the time it neared its closest solar approach, the object was no longer simply unusual. It was behaving in ways that forced even the most conservative analysts to acknowledge that something inside it or about it was changing. And whatever the cause, the timing felt too precise to ignore. The perihelion window began with a surge of new observational data. The first surprise came from the photometric trackers. For the first time since its discovery, Atlas displayed a measurable shift in its surface reflectivity. Not a chaotic flare or fragmentation event, as we typically see when a comet confronts intense solar heating, but a gradual, coherent brightening across several rotational phases. When we plotted the curve, the increase formed an almost symmetrical wave pattern. Natural? Possibly. Predictable? Hardly. What unsettled me was the transition. Instead of flaring abruptly, as volatile rich bodies often do, Atlas brightened in a manner that resembled a controlled modulation, like a surface gradually adjusting its reflective properties. Several colleagues suggested exotic materials, perhaps metals or crystalline structures reacting to thermal expansion, but one analyst pointed out that the reflectance rise matched no known response curve. It was neither purely thermal nor purely structural. It fell into a strange category between the two. Meanwhile, deep spectrum radar systems running simultaneous sweeps detected unusual behavior. The earlier coherence peaks, those faint internal reflections hinting at layered density zones, became sharper. Their spacing narrowed slightly but remained proportionally aligned, almost as if whatever internal structures produced them were shifting into a more compact configuration. The official explanation described the effect as thermal influence on subsurface heterogeneity. But privately, many admitted the result resembled an internal rearrangement rather than passive heating. The next anomaly came from magnetometric readings. Several solar monitoring instruments registered a faint distortion in the local magnetic environment surrounding the object. It was extremely weak, barely above background noise, and would have gone unnoticed if not for the earlier anomalies. But when we mapped the distortion over time, it displayed a pattern aligned with Atlas's rotation. Again, not strong enough to declare anything, but persistent enough to feel intentional. Then the radio fluctuation returned, stronger this time, not a signal, not a transmission, but a structured irregularity in the background spectrum. Over several hours, the noise floor rose and dipped in sequences that resembled envelopes rather than random spikes. When the data was smoothed, the envelope shapes appeared loosely periodic. Even the skeptics stopped speaking in absolutes. The leading theory suggested a natural resonance between the object's surface temperature and nearby solar plasma fields. But no one was fully convinced. The timing matched too closely with the other active phenomena. As Atlas curved past the Sun, the most surprising development emerged. A sharp trajectory correction appeared, tiny but unmistakable. The shift did not align with the predicted influence of the solar wind, nor with rotational torques. Instead, it mirrored the direction of earlier deviations, forming a continuous trend that could be traced across several weeks of data. Natural forces rarely organize themselves into such smooth arcs, but when I plotted all the course adjustments on a single chart, something about the pattern made me pause. It looked less like a drift and more like a guided pathway. At this point, internal discussions took on a different tone. Not alarmist, analysts avoid that instinctively, but tense. Every room I entered felt as if the air had thickened. People spoke slower, they paused longer. They questioned their own interpretations before questioning others. Atlas had become a puzzle that no one wanted to solve too hastily. Then one final piece of data arrived, one that pushed the entire discourse to a new threshold of ambiguity. A multi-observatory infrared sweep conducted immediately after perihelion registered a momentary, extremely narrow thermal spike, not across the surface but from a specific point, like a flash of concentrated heat. It lasted less than a second, too short for mechanical activity, too long for a noise spike, and what made it truly strange was its spectral purity. Natural thermal bursts usually contain a spread of wavelengths. This one was unnaturally clean, as if something emitted a single finely tuned pulse of heat. When the data was presented, a long silence filled the room. No one rushed to explain it. No one dismissed it either. It simply existed, a thin, undeniable line on a chart. What could produce such a phenomenon? Exotic mineral microfractures? Sudden reflection of solar radiation? An instrumental glitch? All possible. But the spike's wavelength did not match any known artifact produced by the equipment involved. And once again, the timing aligned too perfectly with Atlas's rotational cycle. One of the senior analysts finally broke the silence. "Whatever is happening," he said, "it appears to be accelerating." He didn't elaborate. He didn't need to. Now, as Atlas begins its outbound journey, the object is quieter, but only in the way something becomes quiet after revealing just enough to change your assumptions forever. The anomalies haven't disappeared. They've simply shifted into forms we don't yet know how to interpret. All the patterns, the reflective modulations, the radar coherence, the magnetic distortions, the radio envelopes, the micro corrections in trajectory, together form an image that is neither clearly natural nor comfortably artificial. It sits in a liminal space between explanation and uncertainty. And as it drifts away from the sun, carrying its unanswered questions with it, one thought keeps resurfacing. If the perihelion phase was a moment of awakening, adjustment, or activation, whatever term one chooses, then the outbound leg of its journey may reveal what that awakening was for. Whether we're ready to witness that is another question entirely.